Welcome back to the channel. So this is continuation of the pin jointed framework solution. So on this part, I finished off the last one with this is the 45-degree one. This is the 26.57 one, VBC, HBC. Cos 26.57 is HBC over BC. So HBC equals BC cos 26.57. Sine 26.57 equals VB over BC. VBC equals BC sine 26.57. That's that one. So this is sheet 5. Sorry about the scribble there. From previous sheets, we have established that HBC equals HBD. Therefore, and that HBC equals BC cos 26.57. HBD equals BD cos 45 degrees. Therefore, we can now say, substitute these terms into this equation. BC cos 26.57 equals BD cos 45. BC equals BD cos 45 over cos 26.57. BC equals BD times 0.707 divided by 0.8944. Therefore, BC equals 0.790474 BD. Okay, so that's done. Sorry about the presentation, I'm going to sort this out. We can now substitute for BC into the vertical equation equilibrium. Overall, vertically on the structure we have at the joint. Overall, vertically at the joint we have everything equals 0. So VBC up plus RB up minus VBD down equals 0. VBC is in tension up, reaction RB up, compression VBD down. Therefore, VBC plus RB is VBD. So we can substitute for VBC and VBD in terms of BC and BD, i.e. we know that VBC equals BC sine 26.7, therefore B and BD, VBD equals BD sine 45, therefore BC sine 26.67 plus 13.333 equals BD sine 45. That's equal to 0.449 BC plus 13.333 equals 0.7071 BD. Remember that BC equals 0.7905 BD. Therefore, 0.449 times 0.7905 BD plus 13.33 is 0.7071 BD. 0.355 BD plus 13.33, 0.7071 BD. Therefore, 0.701 BD minus 0.3, I think that's 55 BD equals 13.33 kilonewtons, and 0.346 BD equals 13.33 kilonewtons. Therefore, we can now solve and conclude that BD equals 13.33 divided by 0.346 equals 38.526 kilonewtons. BC equals 0.7905 times 38.526, as BC equals 0.79 times BD, therefore BC equals 30.455 kilonewtons. So I'll put that on the diagram for the results from resolution of joints, equilibrium of joints at B. DB equals compression 38.526 kilonewtons, and BC equals 30.455 kilonewtons in tension. So that's just that wraps up joint B. So I'll see you in the next video. We're going to do A, joint A, then we're going to do joint C, and then we're going to check everything at joint D. Hopefully you enjoyed the video. Please like the video, please subscribe to the channel, then I can do more. This is from T.R. Graves Smith, Linear Analysis of Structures, Chapter 2, Internal Forces. Thanks, I'll see you in the next video. Thanks.